technically, now we are coming back, we actually ask our students, what should be the question we ask next? Right?
Right.
So, Ivan, why don't you write this down? Except writing this, write everything else. And let our students fill in the blanks.
So how many colorings are there
For which?
for which is red?
And this time actually are red. Right? We are giving our students a hint. There's something you need both of them. Right? So what do you guys think? What you can fill in here? Right? Give it a try. So what we can fill in?
We can fill definitely S1 and S2. They can be read at the same. So S1 and S2.
And then cyclic rotation wise, S2 and S3.
S3 and S4.
Uh-huh.
S4 and S1.
Yes.
Right? Because they overlap.
Yeah. So basically they all give you two consecutive ones. Right? And what else? Anything we are missing?
We do.
Mm-hmm.
S1 and S3, they also intersect, but they have only one square.
Yes.
But still they
can overlap.
so
they can
plus,
coexist.
Yes, S1 and S3
Uh-huh.
and plus S2 and S4.
Good.
So in inclusion-exclusion principle, you should think of any possible pairs.
Mm-hmm.
If they do not intersect, you take out 0.
Mm-hmm.
If they intersect, you need to subtract colorings.
Right, because for example, we are talking about this particular coloring, it appears in S1 and S2. But technically, we should only count them how many times? Once. Right? But in this counting, we count them twice. So that means we have to subtract out what? One of them. Right?
Yes.
So
Yes.
now this one becomes only once now. Right? So for example, what I'm talking about is this guy. Red, 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 right? This particular...
Wait, red means blue or red means...
Oh yeah, blue. Sorry. Right? Blue.
Yeah.
The color. So this tells you this particular guy, for example, it counted once in S1, it counted again in S2, but now we have to take them out from S1 and S2. So this guy right now being counted once, subtracted out another once, then we counted once, right? Which is correctly so. Right?
So now, once we have questions, you guys can find answers. How many elements in each of these sets?
Right.
And did we count everything up to now?
Right. Be careful. So this is what we call the second step. It's exclusion. We include everything. Now we have to take out the what? The common parts. Okay? So yeah, go ahead, count those values. Don't erase that guy. I'm going to write down those numbers over here, right?
Mm-hmm.
Okay? So S1, S2, like we said, you fix 6 of them. You have 3 variables. So 2 to the 3.
2 to the 2 cube, 2 cube, 2 cube.
Yes.
These are
definitely
different.
Yes.
So if you have a green one and 2 red squares,
like this.
Like this.
So you only have 2 what? Freedom here, right?
So this is free,
Uh-huh.
and this is free.
Right.
Right now.
Yeah.
2 squared.
Yes.
2 squared here and 2 squared here.
Right. So our accounting, if we count the tracking, now we have 2 to the 5th times 4, this 4.
Yes.
Now we have to subtract out what? This overlapping, all overlapping ones, like this, right?
Yes.
So that's 4, 2 cubed,
and 2
plus 2,
2 squared.
2 squared. Right? Are we done? We included them. We also exclude them. Technically seems like we are done. Right? Do you guys think we are done yet? Usually when we ask this question, you should know the answer is no. Right? But you need to ask yourself, Why not? Why we are not done? We finished the inclusion and we did the exclusion. So what went wrong? Okay? If you think about there's something could be wrong, you draw a special grid to tell me this grid now is in trouble.